The nth term of a geometric progression is given by 180 half power n. Find the first three terms and the common ratio as well as the sum to infinity of the progression. So how do you deal with this particular problem? Notice that we are dealing with the geometric progression. This means that when we are trying to calculate the nth term, the formula for the nth term is given by a r to the power n minus 1. So this is the standard formula for the nth term when you're dealing with a geometric progression. Now notice that we have the formula for the nth term given by 180 half to the power n. So when you look at the first question, notice that we need to find the first three terms. And since we are finding the terms, this is the formula that we need to use. But since we've been given the nth term, which is here, then we just need to use this same formula which we've been given to find the first three terms. So this is the first question. So the first term is going to be this n, which is the first term. And here we have, notice that we have 180, and then we have half. And where there is n, we can put the nth term here, which is 1. So here we're going to have 180 half. And so 2 into 180 is actually 90. And so 90 is the first term. What about the second term? Well, for the second term, the value of n should be 2 because we are dealing with the second term. So here n is equal to 2. So we can go ahead and plug it into the expression that we have. So here we are going to have 180 and this is half power 2. So this is going to be 180 and here we're going to have 1 over 4. So 4 into 180 is equal to 45. So 45 is our second term. Now we can go ahead and find the third term as well. So for the third term, the nth term should be 3. So the value of n is 3. We can go ahead and plug it into the expression as well. So this is 180 and here we have half power 3. So this is going to be 180 and this is 1 over 8. So what is 180 over 8? So if you do the math, this is going to give you 22.5. And so this is the third term. So you can write this and say that the first three terms are, so we're going to have 90, then 45, then 22.5. And so this is the answer for the first question. What about the second question? How do we find the common ratio here? Notice that we are not finding the common difference. When we have terms like 2, 5, 7, 9, you understand that when you're dealing with arithmetic progressions, the common difference is the second term minus the first term. So in this case, it will be, this is the first term, this is the second term. So you're going to have 5 minus 2 or 7 minus 5 or 9 minus 7. You're still going to get the same answer. That is if you're dealing with the arithmetic progression. But since this is the geometric progression, we're not finding the common difference. Notice that here we are finding the difference. we are subtracting. But for the geometric progression, we are dealing with the common ratio. So for the common ratio, notice that it is called the common ratio. So instead of finding the difference, we are finding the ratio. So we are going to have the common ratio, which is going to be the second term over the first term. So this is the ratio. So in this case, we can have, this is the second term, so it's 5 over the first term, which is 2. So this is the common ratio for this particular one. So let's go ahead and find the common ratio for this particular progression. Now, notice that we have the nth term already. So in this case, when you look at the formula for the nth term of a geometric progression, it is a(r) to the power n minus 1. So in this case, it's very easy to get the common ratio, because you can even get it directly from here, because this is the same as this. However, let's just use the formula to get the answer for this particular problem. So here the common ratio, remember, is given by the second term over the first term. Now remember that we have 90 and 45 and 22.5 as our first three terms. So 90 is the first term, and we can just say that 90 is the first term, 45 is the second term. So here where there is the second term, we are going to have 45, and where there is the first term, we are going to have 90. And so 45 into 90 is still going to give us half. So this is the same half that we have here, and this is our answer. Now what about the sum to infinity? How do we find the sum to infinity of this particular progression? Well, whenever you're finding the sum to infinity of a progression where r is less than 1, the formula is the sum to infinity is equal to, this is a over 1 minus r. This is an important formula that you need to remember. So all we have to do is we can go ahead and plug in the values into the formula to get the sum to infinity. So the sum to infinity is going to be, what is the first term? Remember that the first term here is 90, and this is going to be 1 minus, and the common ratio is half. So this is half. This is going to be 90 over half, because 1 minus half is half. And so our final answer is going to be 180. And so this is our sum to infinity.